the energy of the future labs in academic and research, which will help accelerating your journey toward strategic objective of Kingdom Vision 2030. Now I will give the mic to Mr. Ashot so he can start with the first part, the energy labs.
Thank you, Michael. Thank you for your very nice introduction. Here at Bitlismen, we equip students, professors, and scientists for next generation industrial revolution. So we believe the tools and skill sets required from the Industry 4 are totally different, and this is what we provide for our customers. The company is established in 2004, and we are an academic partner as well as the award finalist. So Bitlismen provides energy-related trainers and research platforms for high schools, vocational colleges, universities, research institutions, as well as for the power industry. We have delivered our trainers in different countries worldwide, including Singapore, Vietnam, Saudi Arabia, UAE, Bahrain, Jordan, Pakistan, CIS countries, Hungary, Chile, and others. And right now we are expanding to the India and the USA market. So today we would like to present you the Power Labs ecosystem product family. It consists from a wide range of energy trainers, from traditional to renewable power generation, transmission, distribution, and protection. The trainers are from the same product family and are fully compatible with each other. This means that the trainers can be used individually as well as in combination with other trainers. So this approach provides additional flexibility to build different scales of the labs, from the very basic ones to the advanced ones, including the smart grid functionality. So what differs us from the competition is the fact actually that we are not trying to sell this product specification, rather than we are providing the value, the vision to our customers. For this, we have students-focused core values, which are do by your own, mean the actual experiment should be implemented by the students. Make your mistakes, so the system has the fail-safe ideology. No matter what kind of mistakes students, it will never harm neither the student nor the trainer. So the next one is the define your trainer, which is very usable for the cases where we are trying to bring to the market the project-based learning, because the products are software defined. Like you can change the software algorithms and redefine the overall functionality of the system. And last but not least, the learn by the feeling, which means that the learning curve should not be based on the memorization, rather than by understanding and feeling what is happening behind. The second direction is the research direction, as I've told, and we have another core values towards the research direction. One of them is the openness of the platform. So we provide open source codes for all our customers. So they can firstly review how it is done, modify it, and come with the totally new algorithms for the solutions. The second one is the software-defined functionality, means as soon as you will change the software, the overall behavior of the platform will be changed. The next one is the software platforms integration, whereas different researchers might find or different algorithms and sections in the MATLAB, Python, or other programming languages. So the benefit of this integration is that you can bring all these source codes to this existing platform. We are using the lab graphic language, so even though the customer might not have experience in the programming, he can still do these modifications and additional research activities. Into this, we are integrating augmented reality, artificial intelligence, industrial IoT, power hardware in the loop, which I will describe
Sorry, audience. Maybe we lost Mr. Ashot. We'll be waiting for him again to join.
Chicago. Check this. Yes, sorry for this technical delay. I hope you can see the shared screen once again. Okay, so I would like to bring a couple of differentiators for your attendance. So we provide the advanced software as well with the state-of-the-art hardware, which allows investigation of the steady state as well as the transient effects. In addition, we use the industrial components in our trainers, and as far as it is possible, we are using either transparent enclosures or we are visually showing to the customer and to the students, both for the researchers, how the mechanically as well the systems are composed. In addition, we are providing enhanced safety for the trainers. So the comprehensive user manual is another differentiator which we provide, and I would like to ask Gevorg, a colleague of mine, to showcase to you that one.
Sorry, I was muted. Now I will present a sample manual of our trainers, and like the same structure we apply for all of our trainers inside the product Power Labs ecosystem product family. So we provide two types of user manuals to our customers. One is for the instructor, and the other is for the students. The main difference is that the instructor one has all the necessary information about how to install the system and how to set it up, and also has all the answers to the questions inside the experiments. So as for the sections, we have hardware software configuration, we have safety instructions, we have troubleshooting list, etc. And then we have the list of experiments. Inside each experiment, we provide the lab objective, where we describe what is the aim of this experiment and what are the users going to get from it. Then we have a theoretical background related to the experiment. It has all the photos, pictures, equations, and related to the topic. So as you could see, it's very comprehensive and detailed. And after this theoretical part, we have some assignments related to that part, where we provide 4 multiple choice questions and 1 open question where the students should describe the answers by themselves. After that, we describe what are the exact modules that are used for that experiment, because all the trainers are modular and each experiment may use certain types of modules. After that, we describe the software user interface. And then we, in a detailed way, describe in step-by-step what the student should do to implement the experiment. We also provide the list of connections that the student should implement on the trainer. And after completing these connections, like he passes to the actual implementation of the experiment. Inside some experiment, we have sub-experiment, which means that inside one experiment, they will do several different experiments, like investigating different characteristics in different modes, like in this example. And then in each part, they are asked to get certain measurements from the software and fill those inside the tables. And after that, they might be asked to implement certain calculations or build some curves related to the topic. So this is the overall structure of the user manual, which can be applied, which is applied to all of our trainers. Thank you, Ashot.
Thank you, Gevorg. Thank you for a very nice explanation. So let me proceed with the presentation. So as I was telling, the systems can be used with the multi-purpose use under the hood. So it can be used for the undergraduate course experiments, for the undergraduate senior design project, postgraduate and research projects, joint research projects between academic and industrial customers, as well as for regular education activities, as well as for the integrated solutions where we would like to join different components for the Power Labs ecosystem together. In addition, we would like to take a couple of moments to describe what are the energy of the future technologies we are bringing to the market, together with this Power Labs ecosystem as an add-on. Those are augmented reality, where we are bringing the 3D models, digital twin, IoT functionality, mixed power microgrids, whereas we are collaborating with the Opel RT, with the real-time power hardware in the loop configuration. We are bringing the artificial intelligence from the machine learning, deep learning, and neural networks perspective to implement additional power quality analysis. And we are as well integrating the solutions with the PTC ThinkWorks, which is Industrial IoT Gateway. And we are providing the distance learning functionality, which is one of the hot topics currently due to this COVID situation, whereas the students can remotely have full access, including the wiring and the video streaming for the trainers. So I would like to here present you a short video for the augmented reality.
Hi, my name is Gevorg. I'm a systems engineer here at Bitlismen. Today, I'm going to demonstrate one of the features of our iLab platform, the augmented reality. Firstly, we will connect to our solar power generation trainer through the AR platform and demonstrate the disassembly and assembly of the trainer, and also the remote control and monitoring of the trainer through the AR platform. Secondly, we will connect to the digital twin of the wind power generation trainer and manipulate with the wind blades. So let's get started. Now I will disassemble and assemble the digital twin of the trainer. Now I will run the trainer. As you can see, we can see the real-time data both on the software of the trainer and also on the augmented reality. Now I will ask my colleague to change the light intensity. Now I will turn off the trainer. Now we will detect the digital twin of the trainer. And now I will press the button and rotate the blades.
Thank you, Gevorg. In addition to that, I would like to present you the distance learning functionality.
Renewable Energy Remote Lab, which consists of 3 parts. The solar energy trains the students on how to get acquainted with solar power plants, simulates a real solar power in off-grid mode, and study operation in battery charging mode. The wind energy trains the students on how to get acquainted with wind turbines and electrical loads, studying the methods for calculating power parameters and study operation in battery charging mode. The fuel cell trains the students on how to get acquainted with fuel cell systems and generate electricity through electrochemical reaction. The remote software was developed to access and control the trainer remotely through the web. Students can sign up for a new user to access the main page. A webcam is installed to see the trainer live. Clicking the solar button will let the student access the materials and experiments related to solar energy. Students can gradually turn on the lights of the PV panel, measure temperature, and set the PV panel and sunlight remotely. Clicking the wind button will let the students access the materials and experiments related to wind energy. Students can turn on the VFD and start the fan remotely. Clicking the fuel cell button will let the student access the materials and experiments related to fuel cell. Students can turn on the fuel cell remotely. For each experiment, students can download a Word document file containing lab experiments. The trainer was manufactured by Bitlismen company in Armenia, supplied and installed by Technology Integration in Jordan, which developed the remote software.
So, in addition to this, I would like to pass the floor to Gevorg to present you the remote wiring functionality.
So here, as you could see also inside the video, in our software, whenever you open the software of the trainer, the user has the ability to enter each of the experiments. And after pressing the button of the specific experiment, they will be redirected to a web page. Now I will share that part also. And as you could see here, a certain web page is opened with all the virtual models that are used in that experiment. And here, the students are able to implement the connections virtually as if they would do it on a real hardware. And after implementing the connections, they are able to press the check and apply connections, which sends this connection list to the actual trainer, and the matrix board, which is specifically designed for this purpose, will implement these virtual connections on the real hardware. So this way, the students will be able remotely implement the wiring between the modules, as if they would do in a real lab. Thank you, Ashot.
Thank you, Gevorg, for this nice presentation. So the next one, we would like to bring to your attention the platform as a service functionality. Whereas we are providing not only the full hardware solutions to our customers, but as well we can provide the service to our customers of having the remote access to our in-house equipment. So the benefits here is that the customer will having the access to the PowerLab trainer at a much lower cost. No extra space usage will be needed inside the university. No shipping cost, no custom clearance, no installation costs will be there. So no extra power consumption cost from the university perspective, no maintenance cost, and customers will receive lifetime online support. And they can access the real hardware remotely, so it will be a real accessing, not the simulation. And they will have the access either 24/7 or based on the user-defined schedule. And of course, the unlimited number of students will have this access to the trainers, and this will give as well ability to have all the future modifications, access for all the future modifications of the hardware and the upgrades. So for the access, universities will use their regular online platforms like Zoom, eSpace, and others. We are considering three main subscription plans. So shared monthly plan, shared annual plan, and the difference is that the customer can select for a couple of months or for 1 year fully, where in the shared plan they can access based on the user-defined time slots, or dedicated plan where the customer can access to the trainers 24/7. For early bird prices, please contact the sales at saabrds.com. So in addition to this, we have another live demonstration where I would like to ask Gevorg to present the real hardware for you.
Thank you, Ashot. So okay, so here in our lab, we have a certain setup for demonstration purposes. We have a set of 2 solar stations. One is for indoor, and the other one is located outdoors. And there we have like a battery and charging system. We have the inverter, where we can also showcase the off-grid operation and on-grid operation of the solar power stations. And we have a small distribution part and transmission part and consumers. So here, as you could see, all these connections are done by the students. It's very straightforward. Whenever they have a list of connections, they are able to implement the connections. It's very safe for them. And also on the software, they are able to monitor all the measurements and electrical and also non-electrical parameters. And also they are able to implement control. From the software, on the trainer, they have different buttons. They can turn on and off the transformers, the different bus bars, the switch gears. And on the software, they are able to monitor all the parameters. If we, for example, go inside, here we can see that they have all the control over the trainer. And here I will turn this on also. And here we have, like, on the software side, we have the different tabs where they can monitor different parameters like the sine waves, the basic analysis, like the RMS values, the frequency. Actually, we try to provide an advanced power quality measurements inside the trainer, so they can investigate different phenomena in the trainer. We provide the active, reactive, and apparent powers, power factor, harmonic analysis, and also, as long as this setup is built as a small microgrid, we also provide some SCADA functionality like alarms and event handling. So, and in the future, we are planning to also integrate the power hardware in the loop simulation provided by OpenRT. And in the near future, we will come up with a new demonstration with this new approach calling mixed power microgrids.
Thank you, Gevorg. Thank you very much. In addition, we have planned to showcase you a couple of case studies and the customer feedbacks from multiple universities in the region.
Hello. Myself, Ramani Panda. So I'm a tutor here in the engineering department in electrical engineering. Bitlismen has incorporated some industrial-based protocols into their jigs, and which is quite helpful for students to have an industrial experience. And in terms of the hardwares, they have a good quality hardwares, and the trainers will be durable. Students will be able to do some more experiments on this one, because it is customized, so we can add some more experiments besides whatever experience they have provided. So this is one of the advantages. And also for researchers also, they can extract some data by performing some experiments in these jigs, which will be quite useful for them also.
So this one is from Saudi Arabia itself, the King Fahd University of Petroleum and Minerals. And let me read the feedback for you. So very comprehensive experiment. The system is very flexible. Everything was thought about, including the minor things. System is protected very well and uses industrial components. Software is open source code, very friendly and nice looking. System is modular and didactic. Students will enjoy it, as well as it's good for the research activities.
My name is Nicolas Vasilikos. I am from Greece. I work in Bahrain Polytechnich. I'm a mechanical engineer lecturer. Now, the last 3 years, except from the engineering part that we have here at Bahrain Polytechnic, I have another course that we make manufacturing process, and in this course, we create small projects with solar panels. I would like to thank you, first of all, Bahrain Polytechnic, and because continuously take devices, a new device for experiment in order to improve the knowledge for the students, to improve the development of the teachers. Second, I would like to many thanks to Bitlismen and its partners because they were very, very useful for us We had a very good training. All of us, the teachers, know how to engage the students in the devices, what is the main function, what is the benefits that we can take from all these devices, from the solar panel, from the outdoor solar panel, from the wind tunnel, how to use the wind tunnel and solar panel together. All this is very useful and can develop the knowledge of the students in order to understand better the renewable source of energy. I would like to say that all these devices are very useful because this is new devices. These devices follow the new technology, and we can make not only the experience that we have here, but we can create a new experience by ourselves. We have here in Polytechnic one tracking system in one building of us, and we take measurement for solar radiation, and we can measure the energy of this solar panel. We can make measurement and we can compare the measurements in real life from one building and the measurement here from the solar panels, as you can see here, and we can compare the sun angle with the angles that we can create with these lights. Of course, this is as experiment in standard technical conditions that the most of the factors used in order to have the better results, the better efficiency from the solar panels that they produce from the society. Thank you so much, Bitlismen. I hope that we will meet again in the near future for new devices. Thank you so much.
Thank you. And this is another case study from Al-Qura University for the mechanical engineering. And here I would like to as well to read the feedback for you. So I believe the outdoor solar power generation research system installed at UQ Solar Lab site is an excellent teaching and research tool that will improve our department capabilities and industry-based teaching. Thank you again for your presentation, and we will keep you in our contact for further collaboration opportunities. And from different professors from the department, very good system. Here everything is put based on industry and education combination. It's perfect for research and limited only on your imagination. This kind of platform should be for all the research areas. It's a must. So those are kind of the feedbacks we are getting. Thank you very much for your time, and we will be more than happy to answer your questions, if any. Michael, the floor is yours.
Okay, so I will start now with some question we got from local end users in Saudi Arabia and Bahrain. So now the first question, Ashot, it's for you. Do you provide local installation and training for the trainers?
Yeah, thank you very much for the question. Yes, we do. We do have our partners, and in case customer would like to, we are in our own engineers are visiting the customers and implementing all the local activities. And of course, in all the cases, we are providing the training and after-sales support for our customers.
Okay, excellent. Also, we got another question related to what type of power measurements are implemented in your trainers. Also, we get a question, where can we get more details about the trainers you offer?
Yes, Gevorg.
Yes, thank you for the question. So regarding the first part about the power measurements, as I shared inside the software, we provide very advanced power quality measurements, starting from RMS values and also having the sine waves of the power signals, where they can study not only the static effects, but also the transient effects. We provide advanced harmonic analysis up to 64th harmonics, all the power measurements like active, reactive, and apparent, the power factor. On the where the three-phase system is applicable, we provide also the vector diagrams flicker measurements, etc. So what was the second part of the question?
The second part was, where can we get more details about the trainers you offer?
Yes, you are free to contact us or or your local distributor in your country. You can also contact SAAB RDS, where they will provide you the full catalog. I guess all the participants will get the catalog of our products, where they can get more detailed information. Of course, as per their request, we can also organize separate calls with them to answer their questions if they have any.
Thank you, Gevorg, for your clear answer. Now, I got this question. What are the pricing options for the subscription plans? Can Ashot or Gevorg answer this?
Yeah, I guess for the pricing, they can approach to the email and get the clear quotation based on their requirements. So I would encourage to contact us or our partners in the region so to get the quotations.
Okay. We have a question, I guess. I have the answers. So they are asking if we can get the recording of this webinar. Yes, of course. We will be sharing with all attendees and people that registered in this webinar to attend to watch the recording so they can get back to us later on if they have any question. Last question, what are the power ratings of the trainers? Gevorg, can you answer this?
Yes, actually it depends on the type of the trainer, but like in generally speaking, they are limited to a couple of kilowatts, like the required power. And regarding the voltage, we build it in accordance to that country that the customer is located in. So it can be 120 volts, it can be 220 volts, 50 hertz or 60 hertz. So we build in accordance to their power regulations.
Thank you, Gevorg. So this is all from my side. Do you have any additional questions, live questions, audience, so we can answer them now? Thank you, Dr. Lasad. Thank you for joining. So now we will end up our event. It reached the end. Thank you for all your questions, feedback, and most importantly, thank you for your time. We were honored to have you in our event, and please reach out to me for any further questions. We will be more than happy to hear your problems and provide you with the right solution. Have a great day. Thank you all.
Thank you very much.
Thank you. Thank you.
Thank you for all. Thank you.